You know, when you drive past a massive industrial facility at night, like an oil refinery or a chemical plant or a power station, it just looks completely chaotic.
Oh, definitely. It's overwhelming.
Yeah, it's just this massive, tangled jungle of steel pipes and towers and blinding floodlights. And I think the assumption we all naturally make when we're looking at it is that it's completely rigid.
Right. Most people look at those facilities kind of like they would look at a skyscraper. Just static, solid, locked into the concrete to, withstand the elements forever.
But the reality is completely different. Those facilities are actually meticulously engineered, almost like living organisms. I mean, at any given moment, there are thousands of tons of high-pressure fluid rushing through those pipes.
And subjected to boiling heat and extreme freezing cold.
Exactly. If that metal jungle was actually rigid, it would literally shake itself apart or tear itself right off the structural walls within hours. So, for today's deep dive, we are looking at the exact paperwork that keeps that jungle from collapsing.
It's fascinating stuff.
It really is. Our source today is a highly technical engineering document. It's the scope of work for pipe support works, and it's governed by the global gold standard of construction law, the FIDIC Red Book, specifically the 2017 edition.
Right, and for anyone outside the heavy construction world, the FIDIC Red Book is basically the ultimate legal playbook.
Yeah.
It dictates exactly who is responsible for what down to the millimeter and the very last euro. And this specific scope of work governs a surprisingly complex world. I mean, we're looking at the supply, the fabrication, the installation, and the testing of 5 major categories of pipe supports.
So basically the brackets and springs and shoes that hold the entire industrial facility together.
Exactly.
Well, before we get into the really intense legal weeds of this contract, I want to make sure you, the listener, can actually picture the heavy metal reality of what's being built here. Because, a pipe support sounds like a generic piece of hardware you just pick up at a hardware store.
Yeah, but it's really not.
Not at all. This contract breaks the work down into 5 distinct work breakdown structure categories, labeled PS1 through PS5, and the scale is just staggering.
It is. We can start with what we might call the backbone of the project. That covers categories PS2, PS4, and PS5. So these are your general carbon steel pipe supports, the carbon steel structural steel work, and the stainless steel work.
Right, the stuff holding the standard load.
Exactly.
And the weight ranges detailed in the contract are wild. They map out 5 different weight bands for these supports. So you have these tiny little brackets that weigh under 5 kilograms, all the way up to massive heavy-duty structural frames where a single support exceeds 100 kilograms.
And a facility might need tens of thousands of those basic supports.
Oh, wow.
Yeah. But where the engineering gets highly specialized and where the contract gets incredibly strict is in the remaining 2 categories. So let's look at PS1. These are the cryogenic pipe supports.
Okay, so I assume they wrap these cryogenic pipes in thick insulation just to keep the industrial fluid inside from warming up, right? But the contract puts a massive emphasis on stopping thermal bridging. Is there an actual structural threat if the cold escapes into the support bracket?
A massive structural threat, yeah. We are talking about fluids at incredibly low temperatures. So if a bare steel pipe carrying a cryogenic liquid touches a standard carbon steel bracket directly, that bracket becomes a physical bridge.
Oh, I see.
The extreme cold travels right out of the pipe through the steel bracket and into the surrounding environment. And when that happens, moisture in the air instantly freezes onto the bracket.
Wow.
That thermal bridge causes thick ice to rapidly build up, which just destroys the specialized vapor barriers wrapping the pipe. And even worse...
Make this worse.
Oh, yeah. Freezing standard carbon steel to cryogenic temperatures actually alters its metallurgy. It becomes incredibly brittle, practically like glass.
Wait, really? Just from the cold?
Yes. And then it becomes prone to just shattering under the weight of the pipe.
Okay, let's unpack this, because that means you can't just weld a bracket to a cold pipe. You have to somehow support tons of moving steel while completely isolating it thermally.
Which is exactly why the PS1 category requires these specialized high-density bearing blocks. They're often made of dense polyurethane foam or even compressed wood.
Compressed wood?
Yeah.
In an oil refinery?
Yeah, and they sit right between the pipe and the steel support. The contract specifies they have to accommodate pipes from 1 inch all the way up to 20 inches in diameter. So that requires anywhere from 40 millimeters to 190 millimeters of insulation just to stop that thermal bridge from forming.
Okay, so that handles the freezing stuff. But then we get to PS3, which is the special pipe supports and spring hangers. These are the ones built to handle the sheer force of the system.
Right, the clamp types, the constant spring hangers, the variable spring hangers, and the PTFE shoe types.
Yeah, I actually had to look up PTFE. It stands for polytetrafluoroethylene. It's basically industrial Teflon.
That's a good way to describe it.
The contract requires these special pads so that massive 30-inch steel pipes can literally slide back and forth across the support bracket with almost zero friction as they expand and contract from the heat.
The facility has to be allowed to flex. I mean, if you try to stop a massive steel pipe from expanding when it fills with boiling fluid, the thermal expansion forces will simply snap the steel bolts holding it down.
Just sheer brute force.
Exactly. So the PTFE shoes let it glide. And the spring hangers in that PS3 category act as heavy-duty shock absorbers, supporting the weight of the pipe while allowing it to move vertically.
You know, reading about those spring hangers totally blew my mind. It reminds me of buying a brand new washing machine.
Oh, the shipping bolts.
Yes. You know how when they deliver a washer, there are those heavy shipping bolts sticking out the back? They lock the entire suspension drum rigidly in place so it doesn't bounce around and destroy itself during transport.
Right.
And if you run the machine without taking them out, the whole washer will practically walk through your drywall. These industrial spring hangers have the exact same thing.
They do. The contract refers to them as being in their travel-locked or cold-set position.
Exactly. They arrive locked, totally rigid. And the contract is intensely specific here. Those travel locks can only be removed after written instruction from the engineer and only after the hydro testing is completely finished.
Right, the pressure testing.
Yeah, meaning they fill the entire pipe system with massive amounts of water to test the pressure before the plant goes live. If a contractor pulls those locking pins too early, before the pipes are carrying that heavy water weight, the massive tension in the springs could violently snap upward. It could warp the pipe or cause a major accident.
What's fascinating here is that choreography of installation. It's a major theme in this document. You don't just bolt the metal together. You have to carefully sequence exactly how the facility comes alive.
Yeah, that paranoid level of sequencing is everywhere.
And it applies to the metallurgy itself, specifically in category PS5, the stainless steel supports.
Oh man, they treat the different types of steel like they have severe fatal allergies to each other.
They really do. The scope of work strictly mandates that stainless steel supports must be handled and fabricated in completely segregated areas. They cannot share the same physical workspace as the carbon steel.
Just visualizing that. I mean, if someone is grinding a piece of standard carbon steel on one side of the shop,
Yeah.
and a stray spark or dust cloud floats over and lands on a stainless steel bracket, what actually happens?
Well, that microscopic iron dust from the grinder embeds itself right into the surface of the stainless steel. Or, if a worker uses the same wire brush on both metals, they physically rub the carbon iron particles into the stainless grain.
That sounds bad.
It is. In an industrial environment, especially near a coastline or a chemical plant, that embedded iron will instantly begin to rust. It causes localized galvanic corrosion, which degrades the stainless steel from the outside in.
Wow.
It just completely defeats the purpose of paying a premium for stainless steel in the first place.
That makes total sense. But when you have clean room levels of segregation for stainless steel and custom calibrated springs acting like washing machine suspensions, the immediate nightmare becomes the invoice.
Oh, the billing is a whole other world.
How do you actually manage, measure, and bill for thousands of completely different, highly sensitive components without bankrupting the project or ending up in court?
And that brings us to the financial engine of the FIDIC contract, the unit rate schedule. The contract requires all pricing to be submitted in euros, and the contractor has to provide what's called a composite rate.
Right, a composite rate, meaning the contractor can't just bill for the raw metal, then send a separate bill for the welding, and then another for the delivery.
Nope, not at all.
The contract explicitly says the rate has to include the material cost, the labor cost, the site transport, the testing, plus all of the contractor's overhead and profit. It's a single, all-in-one price tag.
Exactly.
But how they calculate that price tag depends on the exact category of the support, right?
Yeah, the measurement split here is highly intentional. Categories PS1, which are the cryogenic supports, and PS3, the special spring hangers, are priced per number.
Per unit.
Right. Meaning The contractor gets paid per discrete unit installed. One spring hanger equals one fixed price. But categories PS2, PS4, and PS5, so all the general carbon and stainless steel work, are priced purely by weight, per kilogram.
Okay, I have to admit, I got stuck on this part of the contract at first. They priced the basic brackets by weighing them, literally charging per kilogram. But the cryogenic and spring supports are billed per unit. If it's all just metal going onto the exact same construction site, why not just weigh everything?
Well, it really comes down to the economics of mass versus complexity. Basic structural steelwork scales vary predictably by weight. If a structural beam is twice as big, it generally takes twice as much raw material and roughly proportional labor to weld and install it.
That makes sense.
So paying by the kilogram, which they calculate straight from the fabrication drawings, or even by physically weighing it on a scale on site if the engineer demands it, is just the fairest metric for everyone.
But the cryogenic stuff and the spring hangers don't scale that way at all.
Not even close. A variable spring hanger isn't just a heavy chunk of steel, it is a highly engineered machine. The labor and the complexity are in the delicate assembly of the calibrated coils, the locking mechanisms, and those sliding PTFE plates we discussed.
Oh, right.
Same for the cryogenic blocks with their multiple layers of vapor barriers and specialized sealant. If you paid for those by the kilogram, the contractor would lose massive amounts of money on the complex labor.
And looking at the unit rates, the contract explicitly recognizes a premium unit rate for the stainless steel relative to the carbon steel. I mean, the employer clearly knows they are paying extra for that segregated handling, the separate tools, and the separate clean rooms.
The FIDIC framework thrives on this exact level of granular risk allocation. The employer wants cost certainty per kilogram and per unit, and the contractor wants to make sure they are paid fairly for complex work. But it's crucial to remember that a FIDC contract has teeth. Severe teeth.
Let's talk about those teeth. Specifically, subclause 13.1, the right to vary, and subclause 8.6, rate of progress.
Under subclause 13.1, the employer essentially holds the cards. They have the absolute right to instruct variations, they can change the design, they can add 300 new pipe supports halfway through the project, or just modify the scope.
And the contractor just has to adapt.
Yes, the contractor has to adapt. But subclause 8.6 is where the true financial pressure sits on the contractor regarding the schedule.
Okay, let's play out a scenario. Say the contractor is waiting on a shipment of those highly complex variable spring hangers from a specialized manufacturer in Germany. The shipment gets delayed at the port. The contractor falls 2 weeks behind the accepted project schedule. What happens under 8.6?
Well, under 8.6, the engineer will formally notify the contractor that they are too slow. The contractor is then contractually obligated to submit a revised working program detailing a recovery plan to catch up to the original deadline.
And the kicker is who pays for that recovery. The contractor might have to bring in a 500-man crew to work night shifts and weekends, paying triple overtime to install those delayed springs. And the contract dictates they have to do it at zero extra cost to the employer.
Yep.
If you fall behind, you pay out of your own pocket to catch up, period.
The employer has locked down the financial risk and the schedule risk, but the highest risk on an industrial plant is catastrophic failure. To guarantee their physical investment, the employer builds an absolute fortress of paperwork. It's essentially an airtight chain of custody for every single millimeter of metal.
I was blown away by the acronyms in this section.
Yeah.
Have the ITP, the inspection test plan, which maps out every single quality check before work even begins. Yeah. You have the WPS, the welding procedure specifications, which dictate exactly how hot the welding torch needs to be and what angle the welder must use.
Very specific.
Yeah. But the ultimate goal of all this documentation is the MDR, the manufacturer's data report.
The MDR is the holy grail of the quality assurance process. It is compiled continually throughout the whole project.
Here's where it gets really interesting. Because the MDR is basically a highly secure birth certificate for every single weld and bracket in the entire facility. Think about the life cycle of a chemical plant. If a pipe bracket snaps under pressure in 10 years, causing a massive leak, the plant operators don't just stand around guessing what went wrong.
No, they have the records.
Exactly. They can go straight to the archives, pull the MDR for that specific support bracket, and see exactly what human being welded it. They can see what specific batch of steel was poured at the foundry, and they can see the exact results of the tests performed on that specific weld on a random Tuesday a decade ago.
And those testing standards are relentless. The contract mandates 100% visual examination of all structural welds. A qualified inspector must look at every single one. but the human eye isn't enough when you are holding up high-pressure boiling pipes.
Right.
So the visual checks must be supplemented by NDE, or non-destructive examination.
This is essentially medical imaging for heavy metal.
Yeah.
The contract lists acronyms like UT, RT, MPI, and PT.
Yeah.
I actually had to look into how these work on a construction site.
They're pretty intense.
Yeah. UT is ultrasonic testing, where they literally shoot high-frequency sound waves into the solid steel and listen for microscopic internal echoes that indicate a hidden crack. RT is radiographic testing. They clear the area and shoot industrial X-rays completely through the steel joint to expose a film on the other side.
And then there's MPI, magnetic particle inspection, where they magnetize the steel and apply iron dust to reveal invisible surface flaws. These tests guarantee the integrity of the metal without having to break it apart. And you certainly can't have just anyone holding the welding torch to begin with.
Not even close. The contract specifies that all welding must be done by coded welders. This means welders who hold valid, current qualifications under strict international standards, like EN ISO 9606 or ASME Section 9. They essentially have to pass a rigorous physical exam, proving they can lay a flawless weld in horizontal, vertical, and overhead positions before they ever step foot on the site.
And the safety parameters extend beyond just the steel. The HSE requirements, health, safety, and environment, call out extreme specific risks based on the work environment. For the cryogenic works we discussed earlier, the risk assessment must explicitly address the dangers of asphyxiation from leaking gas or severe frostbite and tissue damage.
Because of the cold.
Exactly. We are talking about handling materials that can instantly freeze human skin upon contact.
And the rules don't just protect the workers. They protect the geographic site itself. The scope of work mandates incredibly strict environmental controls. They have to prevent any soil contamination or drainage pollution from industrial byproducts.
Things like cutting oils.
Yeah, cutting oils, protective chemical coatings, and spent abrasives from sand blasting the steel. You can't just let industrial runoff seep into the groundwater of the construction site.
Absolutely not. But with thousands of welded supports, thousands of X-rays, and mountains of environmental compliance, you might wonder how a project like this ever officially crosses the finish line.
Seriously, because it feels like a massive industrial build could just be stuck in inspection purgatory forever, endlessly retesting welds.
It could be. But that is managed through the contractual concept of taking over, which is a very specific milestone in the FIDIC Red Book. The project is not considered complete just because the metal is physically bolted to the concrete and the pipes are resting on the shoes.
Right. There's a massive legal difference between physically installed and contractually complete.
Exactly. The engineer will not formally accept the documentation, and the employer will not issue the taking over certificate until every single category, a punch list item, is completely resolved.
And a Category A item is defined as anything that prevents the safe and reliable operation of the facility. It is a hard stop. You cannot turn the plant on if a Category A item is pending.
And even after the employer officially takes over the plant and begins operations, the contractor is still not entirely off the hook.
Because of the DNP.
Yes. The taking over triggers the start of the DNP, the defects notification period. If any hidden defect in those pipe supports reveals itself during that operational period, say a weld fails or a PTFE shoe warps under heat, the contractor is legally obligated to return to the site and fix it at absolutely no additional cost to the employer.
Wow. So let's pull all of this together.
Yeah.
We started this deep dive with a theoretical stack of raw carbon and stainless steel. We learned how that steel has to be handled with clean room levels of segregation to prevent microscopic iron dust from triggering severe galvanic contamination.
Right.
We saw how the cryogenic pipe supports require thick polyurethane insulation to prevent thermal bridging that could turn heavy steel as brittle as glass. We navigated the incredibly strict FEI rules of the unit rate schedule, getting paid by the raw kilogram for static steel, but getting paid by the discrete unit for highly complex, calibrated spring hangers.
Yeah, the mass versus complexity.
Exactly. And finally, we saw how an obsessive chain of custody, the test plans, the ultrasonic X-rays, and the manufacturer's data report birth certificates, guarantees the absolute long-term integrity of a multi-billion-dollar industrial plant.
It is a phenomenal choreography of extreme metallurgy, granular logistics, and unforgiving contract law.
It really is. And the relevance here is that the next time you, our listener, drive past an oil refinery, a chemical plant, or a massive power station, I don't want you to just look at the massive pipes, the cooling towers, or the floodlights. Look closer.
Look at the supports.
Yes. Look at the thousands of hidden structural supports, the discrete brackets, the calibrated springs, and the sliding shoes holding it all together. Every single one of those hidden pieces has its own legal, economic, and engineering pedigree.
They truly are the unsung, invisible heroes of heavy industry. But, there's one final layer to this specific FEI document that completely shifts how we should think about these massive structures.
Yes, and this is the provocative thought I want to leave you with today.
Yeah.
Throughout this entire scope of work, the FEI contract relies heavily on subclause 4.1, which covers unforeseeable physical conditions.
Right.
The contract fundamentally knows that the real world is messy, it's unpredictable, and it's constantly shifting. But at the same exact time, the engineering utilizes those sliding PTFE plates, those variable spring hangers, and carefully planned thermal allowances to intentionally let the massive steel pipes move.
It's a complete paradigm shift from how we are taught to view major construction.
It is. We always think of massive construction projects as the ultimate art of locking things rigidly and permanently into place, conquering nature with brute force, tight bolts, and heavy steel. But actually, when you read a deeply technical document like this, it reveals a profound truth about the built environment.
That it has to adapt.
Exactly. True engineering mastery isn't about stopping movement. It's about predicting, accommodating, and safely choreographing the inevitable shifting, shrinking, and expanding of the physical world. It goes back to what we said at the very beginning of this deep dive. It's not a rigid skyscraper. It's an invisible skeleton. And a skeleton is brilliantly designed to flex, to move, and to breathe.
See the link in the description for free PDF download. Also, watch our other construction scope videos. Thanks for watching. Please subscribe and see you next time.